All right, guys, another thing I found in UT's packet in the Stats 201 is a big section on Z-scores and making sure you understand what they are. And we've done those all year long, so hopefully you got a good feel. But if not, hopefully this review will clear it up for you. So here we go. A Z-score from way back, guys, is a number. All it is a number of standard deviations that a given value of X is above or below the mean. It's how many standard deviations a certain value is from the mean. If you think about it that way, how many standard deviations away a value is from the mean. And the reason we do Z-scores is to standardize data. You know, when we do Z-scores, we make our mean is always 0, our standard deviation is always 1, and that's kind of how we roll with Z-scores. So a couple things I want to show you here about Z-scores, and we'll be done. All right, first of all, the formula for Z-score. It depends on if you're doing a sample or a population, but to be honest, they're really the exact same formula. You take the data value, the X value that they give you, whatever it may be, the X value, you subtract the mean from it, remember X bar is mean, and divide it by standard deviation. That's the sample because we use a little s. If it's a population, the same formula. You take the value, the data value from the population, subtract the mu, which is population mean, divide it by baby sigma, which is the population standard deviation. So really the formulas are exactly the same. It's always x minus the mean over standard deviation. X minus the mean over standard deviation. I might write a song about that. All right. Remember that usual values, if something's considered usual, they will fall within 2 standard deviations away from the mean. Remember doing 68, 95, 98.7? Well, 95% of the values are going to fall between -2 and +2 on Z-scores, which is -2 and +2 standard deviations away from the mean. So if it's usual, it'll be less than between -2 and 2. Anything outside of that is considered an unusual value. Okay, last slide already. Barack Obama has a net worth of $3,670,505. The 17 members of the executive branch have a mean net worth of more than his, $4,939,455, with a standard deviation of, that's a big standard deviation, $775,948. So the first question says, what's the Z-score? To find a Z-score, just go with the formula there. I'm going to say the Z is X, which is his salary, this, minus the mean, which is this one, divided by standard deviation, which is 7775948. I'm going to punch that in real quick. As I punched it in, I got -0.16. Now, I was expecting negative, mainly because his salary is below the mean. Because it's below the mean, you would expect a negative Z-score. Now, part B, that's part A. Part B, is his net worth unusual? You would say no, it's not unusual because it's not far from the mean. It's definitely not 2 standard deviations away from the mean. As long as it's within 2 standard deviations of the mean, it is usual and not unusual. And that's what you're going to be doing in your assignment today, which is going to be on Google Classroom or Google Doc. You'll just be finding, 3 or 4 Z-scores and telling it the value is usual, unusual, or not. But it's a big deal. So good luck with that.